What's going on, everybody? This is Party Boy Arsh here with another physics experiment. Today, I'm doing electrostatic induction. What is that? Well, for I have my electroscope set up. I'm using a wire hanger for my conductor, and I decided to do 7 leaves. My main way of conduction through these leaves is going to be graphite. I decided to do an experiment of graphite because I can kind of take a look at different levels of graphite and see how it affects the experiment. So here I have heavy, here I have medium. Here I did heavy but small surface area. I went to dot with a lot heavy graphite, light dot, light graphite, no dot, no nothing, just paper, and then foil. Decided to do another material that's also conductive, just to graphite and see if there's a difference in strength. So the object that I'm using to use in this experiment for my negative charge is going to be a balloon. So the idea here is that I will be negatively charging this balloon, and we'll place it near my conductor or my conducting wire, and placing it near will induce the electrons in this wire, because this is neutrally charged right now. It will induce the electrons to repel with the electrons that are in the balloon, and it will go its farthest distance away. It will try to get as far away as it can from the negatively charged balloon. So it will travel down this wire, and it will travel down where it meets with my leaves. And because my leaves are also facing each other, it will be 2 negatively charged leaves facing each other, which will make them want to repel. So we will see these leaves repel, and let's see how they repel differently, or if they repel the same, based on their material, amount of material, and size. So let's get started. Okay, first guy I got set up is the one with a lot of graphite. I just kept drawing on it. So I'm gonna grab my balloon. The balloon I chose for this experiment is this balloon, because this is the face I make when I do physics. So here we go. Okay, I'm gonna place it near but not touching, and you can see, well, there's so much graphite on this one, because I've already done this. I've noticed that this one, I see a spark happening, and we saw it jolt. So that's pretty cool. That's kind of neat. So we can kind of see it do that. We might have lost some charge there, so there we go. It did it again. So yeah, so that's that one. Okay, next I have the one that I lightly put graphite on. It's medium size as far as the surface goes. So I even turned it around. Maybe it's point of equilibrium, static equilibrium, I don't know. But this one also sparked again. Very slight though this time. You can see the separation is happening. It's slightly a little bit weaker. So let's go to the one where I put a lot of graphite, but the surface area of the leaf is really small. So let's see that one. You can see it's spreading apart pretty well. So this is at this point of the experiment is when I realized that the scale of this project might matter, because they're all kind of equally repelling as far as the distance goes. I'm back. But the amount of conductive material that I put on it should have some sort of effect, I did see a slight difference, but if I were to do this on a bigger scale, I feel like I would see a bigger difference. So that's when I started to realize that. So the next question that came to my head was, okay, if I'm not seeing much of a difference, let's see how little of graphite do I even need for this to repel, for my leaf to repel. And that's when I started just doing a dot. So the next one is a dot. That's I did a lot of graphite in a little dot. Okay. So we see the repelling. I think there is a slight difference between this one and the first one. Just a little bit less. So this is when I started, okay, there is a difference. That kind of theory of less conductive material was kind of showing a little bit. However, this is when I also started realizing that, I don't know, maybe the main difference here is the source. The source of my static coming through, because if I charge this up barely, like barely rubbed it in my head, and this was not charged up a lot negatively, then that's really what might be controlling how much they're repelling or not. And that's kind of what we did with the balloons in our first lab, where we got to actually calculate, okay, how much is that charge that's happening. So maybe a smaller Q if I barely did it. So, but this is also when I saw that, like, okay, if I can just do dots, then I can pretty much grab a piece of paper and create a circuit on a piece of paper and kind of run electrostatic electrons through a circuit, maybe in a series or parallel, maybe. So that's another thought that came into my head. So next one, I'm going to do a light dot. It's still a dot, but light graphite. Okay, so this is the light dot. Surprisingly, I got a spark out of that, but you could see it's making it even move around. Probably has to do with the weight on my loop on the wire. It just wants to naturally kind of spin around until the heaviest point is on the bottom. So, but I am seeing less, a little bit less on that, on a little bit less graphite. So this kind of made me curious, because I was like, okay, I'm still getting a repelling force here. What if I just do no graphite, if I just do paper? And this is when things got wacky. Okay, so this is just paper. And it's still pulling apart, which is blowing my mind, because paper is not a conductive material. Especially if it's dry paper, it's not conductive. So I started thinking about, what are the reasons? Like, what's going on here? Do I need to discharge my wire every time? Is there too much humidity? I see water droplets in my container, and I know that wet paper does have conductivity. So is that why? Is it because it's in such a small world here? If it was in a bigger world, the water droplets wouldn't be affecting it. Why is it pulling apart? Is there, I don't know. Is it the lines? Because these note cards have lines in them. Is it the ink? So that's what came up. So next I have my foil, kind of like my controls, a material that's purely, it's conductive. It doesn't depend on how much graphite I put on. Okay, this is just the foil, and you could see it's pulling apart really well, really greatly. So I think we can see a difference here between my lightly dotted or lightly graphited pieces of paper and a material that's purely conductive, like the foil. So that was my project for induction, and I thought it was pretty cool. to see the difference in the leaves and kind of think about different theories of why things happen the way they happen. So, would be cool to see this on a larger scale, and hopefully, if I wasn't specific enough or specific about the wrong things in the video, it's things I can clear up in the report or the abstract, as you will. So, yeah, so that's that. So, thank you. Appreciate it. Electrostatic induction. Let's go.